my name is Kit Clement, and I'll be showing you how to solve a Square-1. Your cube may not exactly look like this, because the Square-1 does take many shapes, maybe something like this. I can actually be solving this one though. This was like, paid 50 cents for this, and from Taiwan. Come to think of it, I don't think I didn't pay for this even. Anyways, Square-1 may seem, at first glance, to be a simpler puzzle than the Rubik's Cube, but kind of a different beast of its own. My opinion, it's harder method to learn. So therefore, for this video, I'd really recommend, if you haven't learned the Rubik's Cube already, it's a good idea to know that because it helps for the basic logic of patterns and such for helping to solve this. It's not exactly necessary because I'll try to make it as basic as possible so that you can jump in and just solve this. But I would highly recommend it. The method I'm going to be using to solve this is based off the one on Courtney McFerrin's webpage, which I'll link to in the About section of this video. So if you ever have a problem with my video, check the website. It's the same method for the most part. So you can always just make sure with the pictures they have there. So if something I did confuses you, you can check it there. But if you still are confused even after that, message me, make a video response, do whatever to get my attention. I'll make a video about it if it's a common problem, or just do what I can to see if I can help you out with this. With that aside, let's begin. So before I can start teaching you things about the Square-1, it may be helpful to learn about the Square-1 itself. As you can see in the solved state, there are three distinct layers: the upper, the lower, and the equator. The equator is what makes this puzzle so different, for there's only one place where you can twist the cube in. Just because there's none on this side, none on this side. So due to such this restriction, there may be many instances where the cube will not turn. So when twisting the cube, you may want to make sure there's a break or fault line going all the way around, like this one right here. So you can twist it, just like that. There may be some cases where you line it up, like I've got this one right here, but if I keep going around, you have this piece in the way, which does not allow it to turn at all. Alright, so in order to solve this puzzle, you're going to need to have a basic understanding of what an algorithm is. By definition, there are sets of programs or patterns used to solve a problem. It's a common term used in programming. In terms of the Square-1 though, an algorithm is just a series of twists, which I will give to you, so you can move certain pieces of the cube without messing up the rest of it. So to teach you these algorithms, I'm going to be using notation to identify certain twists of the cube. And unlike the Rubik's Cube, where there are 6 faces to turn, the Square-1 only has 3. Those faces are the top face, this one right here, the bottom face, and then right, which is either notated by R or a slash. The top is T and the bottom is B. I'll probably be using R, just so you know, for this twist right here. So when turning the right face, you will need to turn it 180 degrees, full like this, because if you leave it at just a 90 degrees right here, it's not all the way around and you really can't do much else with it. So in order to actually get a full twist, you need to turn it 180 degrees, just like that. For the top and bottom sides though, it's a little different, a lot less restrictive than the right side here. So we have to use a little more complicated notation. So we're going to start out with T plus 4. And what that means, well, it has 3 parts to it. The T tells you that you're working on the top side. The plus means you're working clockwise. A minus would mean counterclockwise. And it's always determined by the way you look at it. So I'm looking at the top face here clockwise, this way. But if I were looking at the bottom side, it's still that way. But if you see it from the front, they work in opposite ways. So if you've done a Rubik's Cube, you probably understand this before, but just want to clarify that. So clockwise and clockwise. So anyways, back to T plus 4. So we're going to be moving the top face, and it's going to be clockwise. Well, then the 4, what does that mean? The 4 indicates how many 30-degree angles you're going to turn this at. For the geometrically challenged, this wedge right here, this small one, is 30 degrees. This large one, 60 degrees. So with T plus 4, we're going to be moving it 4 30-degree angles. So that would be also 120 degrees. So you can see this as 1, 2, 3, 4. Just like that. So just for the sake of repetition and making sure that you get it, let's do a B minus 3. So we look at the bottom side. It's a minus, so we go counterclockwise, and we turn it like that at 90 degrees. If you simply see something like T plus, it implies T plus 1. It's the same thing. So T plus would just be like this. It's clockwise, top side, and 30 degrees. So I think that'll give you more of an understanding of the notation. If you still need help, there is the link to McFerrin's website, and there's a whole list of all the notation there. So if you need more help with this, I'm pretty sure you'll be able to get it though. So anyways, now we're going to be actually moving on to solving.